Okay, people, in lecture 5 circles, today we are going to discuss about that position of a line with respect to the given circle S is equals to 0. See, already we know that S is equals to 0. This is that a representation of a circle. You know, this one is discussed in the previous videos. This one we discussed in the previous videos. S will be represent either the standard form x square plus y square plus 2 into gx plus 2 into fy plus c is equals to 0. Here this expression x square plus y square plus 2gx plus 2fy plus c, this one is represented with that symbol s, right? Or you can write that x square plus y square minus r square is equals to 0. So anyone you can take, both are represented by s. So either the first one or the second one. So now you are coming to that main concept. So here position of a line with respect to the given circle S is equals to 0 means here this one will be, first you take that one circle. So this one is that position of a line with respect to the given circle. Here this is that a circle, right? This one is that a center. Now this is denoted by S is equals to 0 is that a circle, and line is represented by capital L is equals to 0. This is the line equation. Now here that a line will be in different positions with respect to the given circle. That will be either the line will be cuts the circle in two different points. So in two different points, here that is that one point will be this one and the other point will be this one. Let it be you take this point as that A and this one is that B. Now here in this case, this one is represent a chord to the circle. This one is represent a chord to the circle. Now in this case, so how can we identify the given line is whether represents a chord or any other position? So see here that we can represent it. So the condition will be, here this one is that a perpendicular distance from center to the given line. Perpendicular distance from center to the given line. What is the line equation? L. Now here this one is represents that radius r. So generally perpendicular distance is denoted by d. From this figure you can say that the condition for the chord will be, this one is that r is greater than d. So anywhere either this condition is given, or if the line is represents a chord, then you have to use the condition will be this one, so that you can write that implies by implied. So if a given line is a chord, then the condition will be r greater than d. And next second one is that here this one is that a circle. This one is a circle. Now here this one is a line. If the line will be intersect the circle at only one point, intersect the circle at only one point. Now in this position this line is a represent a tangent. This line is a represent a tangent. So this is nothing but what? L is equals to 0 and the circle S is equals to 0. This one is the center of the circle, right? Now here this is that perpendicular distance from center to the given line. And you know, by observing this diagram, so this is generally perpendicular distance is denoted by D. And here this one is nothing but the radius, right? Now in this case, very clearly, this one will be very clearly, you can write that condition for a tangent, condition for a tangent, tangent condition will be, tangent condition will be, this one will be R is equals to D. So anywhere if R is equals to D, the given line is the tangent, or anywhere if you have in a question tangent, the line is represent a tangent, then immediately we should apply that R is equals to D, right? This is the second case. And next third case will be nothing but, third case will be nothing but, here this one is that this one is a circle, this one will be the circle. Now the line is neither a chord nor a tangent. That means what we can understand, the line is not intersecting the circle, not intersecting the circle. That means here completely the line is that outside the circle, S is equals to 0. This one is that center C. It is that distance from center to the given line. This one is that radius of the circle. This is the radius of the circle. By observing the diagram, now you can say that the condition, if the given line is neither the tangent nor chord. So a line is neither a tangent, neither a tangent nor a chord, nor a chord. Then what is that condition? Then R is less than D. R is less than D. So here R is less than D is the condition for any line is neither a tangent nor a chord. Any line is neither a tangent nor a chord. So please all of you observe that the three cases. First case is that what? So here the case 1 is that you have that R greater than D. R greater than D means now you can write that this is a condition for the chord. Next second case is that R is equals to D. This one is the condition for the tangent. So generally it is called condition of tangency. And the next case will be if any line is neither a tangent nor a chord, then the condition will be R less than D. Say in all the three cases, so it's commonly you can say that R will be represents a radius of a circle. R will be represents a radius of a given circle. Radius of a given circle. Given circle. And what is meant by D? D is that perpendicular distance from center, perpendicular distance from center to the given line, to the given line. So this one is the concept of position of a line with respect to the given circle. So next one more concept is there in this one that will be very useful for any curve equation, not only that circle, any curve you take it, so that is that whatever that, and any line equation. So then the method that is the universal method, that is nothing but alternative method. That is that alternative method is alternative method. It is a very useful in all geometrical concepts. That means you can either apply in the circles or parabola or ellipse or hyperbola. So let s is equals to 0 be the given curve. This one is the given curve. So please all of you listen very carefully. It is a very important concept. And next one is that L is equals to 0 be the given line. L is equals to 0 be the given line. Now by solving these two, S is equals to 0 and this is that, let it be equation 1, and L is equals to 0. This one is that equation 2. So now solving 1 and 2. Solving 1 and 2. By solving 1 and 2, you get a quadratic form. You get a quadratic form. You get a quadratic form. So here the quadratic form, you know, that will be in that which form? That will be generally, you know, in that earlier classes, quadratic expression will be ax square plus bx plus c. So is equals to 0, it is called the quadratic equation. You know, this equation will represent that different roots. Suppose this one is maybe real and different roots. This one is that real and different roots. You know, if the quadratic equation represents the real and different roots, then what is that condition? Discriminant d is that greater than 0. What is meant by d? D is equals to b square minus 4 into ac. So here this one will be represented. This one is represented. So discriminant value. Discriminant value is greater than 0 means obviously the line will be intersecting the given curve in the two different points. So it is a very important point. So if a line is to become a chord, to the given curve, then we have to apply immediately after solving the both equations. So now you use that discriminant. D is that this one is that D is that greater than 0. See, D greater than 0, that is the one condition. This is that one condition. And next, suppose you take that here, this one is that real and equal roots. Real and equal roots. Real and equal roots means you know the discriminant value is equals to 0. So D is equals to 0. You know, any line is intersecting that curve at only one point. So one point means the roots will be nothing but equal. See, we will discuss that we take one example, this one. This is a curve. If the line if the line, this is that curve S is equals to 0, and if the line will be touches only at a one point, then the quadratic equation will be represent only that one root, those roots nothing but the equal roots. So this is the tangent condition. So you can write that any line is to become a tangent to the given curve, you should be apply after solving the both equation, discriminant will be equals to 0. And next one is if d is less than 0, if d less than 0, if d less than 0, then the roots are the roots are imaginary, then the roots are imaginary, then the roots are imaginary, roots are imaginary. So imaginary means discriminant value will be less than 0. Imaginary means discriminant will be less than 0. Imaginary means what? So it has the no real roots. Then the line will be neither intersect nor touches. So that will be like this one. So this is that a curve S is equals to 0, and this is the line L is equals to 0. So in this case, the line is to become neither the tangent nor chord to this one. So in the first case also, you can draw that figure. This one is a line. So if discriminant is greater than 0 means that it has the two real roots. Two real roots means what? The line will be intersecting the curve in the 2 points like this one. The curve will be intersect in 2 points. So this is the one root of the equation, and this is the another root of the equation. So that I hope everyone is clear the concept how to discuss that position of a line with respect to the given curve. So the alternative method is that it's a compulsory, you can use that any different curve equation. It's not to become any standard form. Right? Thank you for watching this video. Please like, share and subscribe this channel.